Hi everyone, welcome back to another session in the Chain Abstraction Educate series. Today we have Kendall from Proximity Labs coming in to give us a talk on apps that work on all chains. So I'm just welcoming him up to the stage now, and then we'll get started. Hi Kendall.
Hey everyone.
Lovely. I will stop sharing my screen and you can share yours.
Great.
How's everyone doing today?
All right. Perfect. Hey everyone. My name is Kendall. I'm a co-founder of a company called Proximity that contributes a lot of research and development to the Near protocol ecosystem. So today we're going to talk about a new product that just went live on mainnet called Chain Signatures, and mainly go into all the cool things you guys can do with it. And then I'll share the docs, and also we can answer some questions and dive into whatever detail people find useful. All right. So the idea of chain signatures is basically this. The idea is that we are spinning up a network of MPC operators or threshold signature operators who are able to respond to requests from near accounts and primarily smart contracts to sign arbitrary payloads. So the TLDR, threshold signatures controlled by near smart contracts or accounts. The major use case we're seeing for this today is effectively using this to take a near smart contract and sign transactions for Bitcoin, for Ethereum, for Solana, for a bunch of different networks. As far as how this actually works, so basically we have a smart contract on Near that has a function called sign, and you basically call this sign function with three pieces of information: a payload, which typically is the transaction or message to be signed, or the hash of the transaction to be signed; a key derivation path. This can be any arbitrary byte string. The idea here is that if a smart contract wants to manage, say, 1 million accounts on Bitcoin, then they can just basically change this key derivation path a little bit and then reliably sign for a different. And then the final piece of information is going to be the key type. So really, this is the signing scheme that you need the network to respond with so that you can create basically a valid signature for a given network or a given blockchain or protocol. So at launch, we have support for ECDSA by default. So this includes every EVM chain, the majority of the functionality on Bitcoin, Cosmos chains, Aptos Suite, Near, and a few others. By popular request, we will absolutely be adding EDDSA, or specifically ED25519, which is what Solana, a lot of substrate chains and others use. So watch out for that pretty soon over the next couple of months. And then in the future, if there are chains or really use cases that require other signature types, we can just add those to the system so that we can support those as well. So to go into a little bit more detail of the interaction pattern between, say, like a near account or contract and ultimately a destination chain, put up this diagram. So basically what happens first is we have this near account that calls this sign function on, this is actually the contract address. On Near, we have these kind of top level domain type of human readable accounts. So like the actual call is the sign function with the payload key derivation path. We'll call it like on this v0.signer contract. It's actually deployed to that account. What happens after that? So this call is made that hits the Near blockchain. It's confirmed, finalized in a block. This MPC network of nodes, which eventually will look a lot like the Near validators. Right now, it's an independent network of professional validators. They are listening for every single request that's made to this contract. When they see a request come in, they start a signature process. In order to do that, what they're looking to do is they first run the Near account through this key derivation function in order to come up with a unique key to sign with. And the reason they're able to do that is together, they basically form like through the nexus of the nodes, and with some minimum threshold, let's say it's 5 of 8 nodes agreeing, they can form a unique public key that they can all sign on behalf of without any one of the individual nodes having access to the private key that corresponds to that public. They can then take that public key, plug in this key derivation function plus this Near account name and also this derivation path, and come up with a unique new public key that only this account can sign for. And that's how they're able to kind of enforce this sort of like relationship of only this account can request a signature for a given key. So they do this process, they receive the request, they pass the information around, generate a valid signature, and they actually return it back to the Near blockchain. It'll actually return as kind of like a part of a callback from this sign function, this completed signature. And what that gives us on the near blockchain is a perfect audit log of, okay, this account or contract has requested these signatures and they've gotten back these returning signatures, these completed signatures, which can ultimately be used to hold these nodes accountable for behaving appropriately. Finally, this near account will receive this signature. So now they have a valid signature that they can form into a valid transaction for, say, Bitcoin, at which point they can send that transaction to the Bitcoin network or Arbitrum, Solana, really anything. And that's the exciting thing here. And then they can have that transaction included in a block on the destination chain. And all of this should actually happen within a matter of seconds. And the idea is that, from the end user's perspective, the way they look at this is, oh, I'm interacting with Bitcoin. We actually have a lot of applications who are abstracting away the entire existence of near in this process, which makes it look like they can do all these cool things with Bitcoin they were not able to do before. So the main takeaway from all of this, if there's anything you take away from this talk, is this: chain signatures enable smart contracts to sign transactions. They're able to do this because of this MPC operator network, which basically gives each smart contract any number of unique keys. There's a couple of products out there that give a smart contract one unique key. We actually give smart contracts any number of unique keys because they can modify that key derivation path. So now smart contracts are able to sign transactions, basically acting as any type of account on any type of network. They can act as EOAs on Bitcoin. They can be part of the signing process of a 4337 account abstraction account on Ethereum, or any combination of these types of behaviors. And they can even do things like asymmetrically encrypt or decrypt information. So there's even some privacy use cases that are possible here from a smart contract. So we're seeing basically teams build around three major use cases. Privacy is definitely one that's, I think, starting to get more popular, but right now it's really these three. And we'll go into them in more detail. The first one is this idea of chain-agnostic applications. So what I mean by that is, we have teams building DeFi protocols like DEXs and lending protocols that are not constructed to actually be aware of the chains or assets that people are trading or using them for. They're rather aware of maybe the public keys or something higher level. And what's cool about this is that this means that as new chains are launched or as new assets arise that people want to interact with or trade or do different things with, these protocols do not actually have to change their core smart contracts or their core kind of design very much or at all in order to support these new applications. And we'll talk about more some specifics on that in a second. Second major use case I put here is specifically DeFi on Bitcoin, because I think that's one, it's a very popular topic right now. Two, I think the experience is still not really there. And we're seeing some teams who I think can actually deliver some really ideal experiences. And then three, it's not just Bitcoin. This could actually be DeFi for any non-smart contract chain, but certainly Bitcoin is what we're seeing the most excitement around. And then last but not least, we see a lot of teams kind of in the wallet space who are leveraging chain signatures to expand kind of the account abstraction, smart contract wallet functionality beyond it just the EVM world or even Solana or Near. We see teams building passkey wallets on Bitcoin or, DAOs that can control assets on any chain and even be managed from various different chains and some broader patterns like that. So to give a couple of more specifics on this chain-agnostic application case, so I think that Oracle is a really easy example to conceptualize. So oracles typically, they do one thing. They bring verified information from outside of a blockchain context onto a blockchain, which then can be, leveraged in any number of products that want to rely on real world information. They don't necessarily, that's what they do. What most Oracle devs want to do is serve anyone who's willing to pay for that information. Typically, they charge that information. That's why we've seen every single Oracle team pretty much fairly aggressively expand to support new chains. And the really challenging part of this is that we're kind of in this virtual machine renaissance right now, which I hope personally will continue, where we have all of these new, Move is getting popular. WebAssembly has been taking off for a few years. We have things like Fuel that are even more specific. And that's all great, except that this means that integration overhead for a team like an Oracle that wants to aggressively spend is really substantial. So in order to alleviate that problem, we actually propose using chain signatures to kind of flip the pattern on its head. Instead, the Oracle can focus on bringing the verified price information onto a single chain, in this case, Near, and then they can actually use chain signatures to then verify that information into a signed payload that can be consumed on any chain, which means that any developer who's, hey, I'm building on Fuel, it's this new chain I'm super excited about. Oh, Pyth isn't available here yet. Oh, well, fortunately, they're signing their payload on Near, and so I can just consume that trust minimized way, and then use that in my application. So that's one example. I mean, we see teams also doing this. AI inference in particular is another use case. We see a lot of this. And then in the cross-chain case, we have multiple teams who are using this same type of pattern to build these chain-agnostic cross-chain dexes or lending protocols. We can use any asset on any chain, or even a public key that corresponds to multiple assets and multiple chains as collateral through borrowing, different things like that. Briefly on the DeFi and Bitcoin idea, I mean, really the idea here is pretty simple. It's bring smart contract functionality to Bitcoin, but let users still just interact primarily or even entirely with Bitcoin. Obviously, this is a hot topic today. And so I think there's tons of opportunity in the lending space in particular. I mean, being able to use like your native BTC in as seamless of a way as possible to borrow ideally natively issued stable coins like a USDC or a USDT, and then maybe even immediately swap that back to Bitcoin on the Bitcoin network. This is something that's enabled by chain signatures. We had teams who are looking at the idea of like how you expand the functionality of runes, build more like true launch pads or just like more performant trading experiences around that. And then even things like passkey wallets for Bitcoin, right? Like you can take advantage of the ability that Near has where we support passkey based wallets. Like you can actually just use like your Apple ID or like your local device, store the keys on your local device, and then easily create a new wallet. And now you can expand this same type of functionality to something like Bitcoin. And then just a little bit on the multi-chain account abstraction idea. I think the most exciting aspect for me here is this idea of using USDC on one chain to then pay for gas on any chain, or even going a step further, where I think a lot of people in the chain abstraction and projects are pushing is use any asset on any chain to pay for gas on any other chain, like getting even further. If you have assets that are valuable that you're able to exchange for some gas fees, that should happen pretty seamlessly. And so chain signatures coupled with some of the near account abstraction functionality is a pretty good framework to base this type of product off of. And then we can really get wacky with this idea of account fi, since what we do is we allow you to basically trade public keys or leverage your public key as a building block. You can get into some really crazy things around this idea of account fi, like trading entire public keys, like in everything that pertains to, or even trading accounts that pertain to locked assets or points or SBTs or whatever are these things of value that historically have been difficult. So to walk a little bit through a very clear example of interaction pattern here on a certain type of application. So I created this example of a runes marketplace just to show you where Near fits into this, where Bitcoin fits into this, and how you can kind of think about some different types of application patterns using this technology. So let's imagine that we have a seller of a runes, like these runes, let's say, exist only on Bitcoin, as they should. And then we have a buyer who, in this case, let's say they have USDC on Near for simplicity, but really this buyer could have any asset on any chain, and this pattern would still work. And then in the middle of them, we have this marketplace contract that is on the Near blockchain, and it's going to be using chain signatures to basically power this interaction between these different networks. So step one, we'll imagine that the seller basically asks the marketplace contract for a deposit address on Bitcoin. It's, hey, where do I send my runes? Kind of like for a user, if you're depositing into a centralized exchange, you ask the exchange, where do I send my assets? They tell you, and then you send your asset there. So in this case, this is runes. And the cool thing, this doesn't actually have to require a transaction. It's possible that the marketplace contract can have a deterministic way to build addresses that's based off of the seller's address. Or there's some really cool ways to do this, so you don't actually have to send a transaction to get the deposit address. So the seller will then deposit the runes into this account that's controlled by this marketplace. Let's imagine that separately to this interaction, this buyer deposits USDC, in this case on Near, because they can do it directly. But again, it's possible to recreate this same pattern where they get a deposit address on maybe Solana, deposit USDC into that, and the marketplace still has control and custody of the assets temporarily, so they can serve as this effective intermediary in a trustless manner. So let's then imagine the seller lists their runes for, say, 10 USDC. The buyer says, great, I accept that. I'm willing to accept that. And then this trade is able to settle. And the cool thing about this is that what's actually happening here is the marketplace contract in its own state on Near is now saying, okay, cool, this seller did have control over this Bitcoin account. Like they were the only ones who could have requested a withdrawal. But now I'm actually, because they accepted the USDC, I'm going to transfer that control to the buyer. So now the buyer can request to move those runes and effectively act as though that runes account controlled by the marketplace contract is in fact theirs. And then the opposite will happen for the seller and the control of that USDC. If it's all on Near, then they'll just receive it immediately. It can actually be withdrawn directly to their account. But if it's on a different chain, they can leave it in that contract. And some of the other cool functionality here is that once the seller deposits and then creates this listing, this marketplace contract can actually prevent them from transferring out those runes in the backend so they can't like potentially rug this buyer. That'll be impossible. While there's an active listing, this marketplace contract can just prevent any withdrawal. So the seller could cancel the listing and then they can withdraw. But if they have that listing open, the marketplace contract to protect potential buyers will be restricting that. And a similar thing could happen with the USDC as well. So yeah, that's the general idea. I'm happy to answer any questions about all of this. I'll post a couple of QR codes here. On the one hand, we've got a link tree that lists to the developer docs, a bunch of code examples that we have showing how you can kind of do this stuff. And then on the right here, we have a link to our developer Telegram channel, where we have not only the team from Pagoda and also our team from Proximity who are building this, but a lot of the ecosystem teams who are building a lot of these patterns. So any questions you guys come up with, we can answer in here as well. But yeah, I'm happy to stick around and answer any questions people have about this, or even talk through some other examples.
Hello, I am back. We've got a couple of questions in the question tab. So first of all, Adam said earlier while you were towards the front of your presentation, you mentioned the term professional validator, and Adam saying he's never heard the term before. How do you qualify to be a professional validator?
Oh, yeah. That's a really good question, actually. So, what I mean by professional validator is there are quite a few validators that are operating as companies, and they do this for effectively a living as a profession where they validate these different blockchains. I wouldn't say it's a requirement necessarily that in order to be, part of this MPC operator set, that you are in fact a professional validator. In fact, like what we want to move to fairly shortly is that this should be like an open and permissionless process that's managed by, a set of strict criteria that ultimately like the near ecosystem and really near stakers most likely will be responsible for setting and updating. And then anyone who's able to meet this criteria of being an MVC operator, will be able to participate in the network. And there will be both rewards for doing so and also like responsibilities potentially, state that will be at risk for that. But yeah, what I meant by professional is that there are quite a few companies, including like the 8 initial operators that we have, that they do this for a living. They aim to be profitable, which yeah, has some benefits, obviously some trade-offs too. Like we do want anyone who is capable and reputable in order to participate. But yeah, just more a description of the initial people than like something official.
Nice. Okay, I hope that, Adam, that answers your question. Another question from Adam is, if the buyer receives control of the Bitcoin account after a rune purchase, what about any other asset that may be held in that account?
That's also a great question. So yeah, I mean, what this would mean is if they do transfer that entire account, then at least in theory, any asset that's under that key will now be in possession of whoever they sold it to or whoever they bought it from. The way we're seeing this born in practice is that in this case, in this marketplace contract, like at least the teams who are building this now, they're generating fresh accounts for each order effectively. So the intention is that only the assets that the seller is trying to sell and this buyer is trying to buy with will be in their respective accounts just to make things clean. And because for users, I think like they're not going to have the mentality, oh, I'm buying a public key. They're going to have the mentality, I'm buying assets. Like I'm buying this specific asset and only this asset in most cases. Now, what's really cool is that you can actually expand it beyond that. This technology does enable you to sell your entire account. If you can sell your public key, that public key might have any number of assets or even positions, like really complex positions that maybe are even like locked or, unable to be liquidated under traditional designs. And you are actually able to sell that. I think that before we see that really take off, like there definitely are some user experience challenges to overcome. Like it's not necessarily that easy to get full visibility into a public key on a bunch of different networks. Anyone who's dealt with indexing is aware of this. So yeah, it's definitely going to take some time before the real potential of that pattern is realized. And so in the meantime, we'll probably see a lot of teams and currently are who really like more strictly use these addresses for very specific purposes. Now, it doesn't stop someone from transferring assets to this account, but they really shouldn't have any reason or knowledge of doing so. So yeah, that's a great question.
Like Fadil has asked if they can get a copy of this deck after the presentation. I think you'd like to go back through the.
Absolutely. Yeah, definitely. Where's the best place to send that? Is more a question for you, Rebecca. Where's the best place to send that?
If you just send it through to me, I can add it onto the Discord chat or send it
Great.
in the email to
Yeah, yeah,
everyone.
yeah.
Uh,
Happy to share that after this.
nice. Adam has thanked you for answering the question. Do we have any other questions about proximity and the work they do, or chain abstraction in general? Because we still have some time left. Oh, Fadila's typing. Okay, we'll give you a minute. Don't need to rush. Do you want to promote yourself? Do you have a Twitter that people should follow?
Yeah, maybe I can send that to you. As I'm not sure even the best place to post that, but yeah, I can send that over as well.
Adam has said, if there's still time, can you go through another example?
Yes, let me find one. Really good to share. Okay, this one I'm quite excited about, and I haven't talked about it in a minute, so happy to go through it. Okay, you guys can see this new. It says cross-chain lending here. Everyone's looking at that. Is that right?
We
Can you
can see
confirm
it
that,
change.
Rebecca?
Oh,
Great. Okay.
yeah.
Now it says cross-chain lending. That's showing to
Now
everyone.
it does. Yeah.
Awesome. Okay. Yeah. So this is building off of some of those same patterns that we just discussed, but it's a little bit more complex, which might be fun for people. So as we talked about, you can use this public key in whatever ways, right? Like you can designate control of this public key to a smart contract. That's basically like the core primitive you need for most DeFi, right? Is that you can designate control of your assets to a smart contract that will follow a predefined set of rules that are basically the rules of engagement for what is effectively, some type of counterparty relationship. And what's really cool, DeFi is like those counterparties can be unknown to each other, and yet they can still effectively collaborate without even really needing a legal system or like our traditional, structures in order to feel confident because they, code is law and it's all it is. But in this case, we assume code is law. So let's talk now. We talked about how we could build a swap-based protocol, but let's ship this to lending. So the core idea here is, I said some things in here like no bridges, all assets are issued natively. What this basically means is that your collateral doesn't actually have to be bridged or leave a chain because you can just be transferring the control of that asset to a smart contract that can sign a transaction on any chain. This also means that, you really expand like the potential base of what you can use as collateral. In this particular example, we assume that loans are fixed rate with an unfixed term. In practice, that of course can change, but just for simplicity. And then we'll also see things like, in this case, borrows are made in USDC on near, which can then be bridged to any chain. And of course, it's non-custodial. So a couple of examples of like how exactly this works. So we'll walk through this with some visuals, but just to lay it out in text here. So step one, let's imagine that a borrower is going to deposit Bitcoin to that near smart contract control. So same thing we showed before, where like if the borrower basically asks the contract for a deposit address and then on Bitcoin and then sends it there. Let's imagine then that the borrower basically requests a loan with some type of set minimum loan amount. So, okay, I put up 1 Bitcoin. The minimum I'll accept against that is 20,000 USDC. And the maximum interest rate I'm willing to pay is something like, 10%. Lenders can then basically bid for this loan in a short-term auction. And the winner will basically be able to, they'll put up the USDC and then the loan will immediately go into effect. The borrower receives the USDC and then the lender basically has their collateral secured by the smart contract that's basically protecting them from, like a decline in Bitcoin price. A lot of this is taken from the design that Blur used because it's a creative way where the contract has no idea what the value of the collateral asset is. So it has to create a marketplace around the loan in order to protect lenders. So in this case, you could have something like a refinancing auction. And again, we'll walk through that, how that could work so that the lender, if the lender's, I need to get out of here, I need liquidity, or even I think the asset is going bad, they can trigger refinancing, which, will basically start escalating the interest rate. And you could even set like a max interest rate. So if no one's willing to accept a 1000% interest rate, then clearly this is like not a healthy loan. And so like liquidation needs to happen, in which case you can transfer the Bitcoin to the original lender who's trying to get out of it so they can liquidate and hopefully recoup most or all of their losses. And then of course, borrowers here, they ultimately do have control in the sense that they can, at any time, they can basically trigger a refinance themselves, or they can actually just pay the loan back and then they'll be out. So to walk through this a little bit more clearly. So similar type of structure before, except now we have a borrower on one side and lender on the other side. And we still have that marketplace contract that's going to be sitting on near and using chain signatures. So same step, same first step. Okay, cool. Got the deposit address. I sent 1 BTC. Lender deposits the USDC. borrower is going to now say, I'll accept at least 20,000 USDC, or maybe they set a max to, and I'll take up to 40,000 USDC at this maximum interest rate. This lender, let's say, bids 5%. They end up coming out with the lowest rate. And so the loan automatically triggers, and basically this user receives that USDC, and this lender is sitting in here and like earning interest on this loan protected by that collateral. So happy path loan origination, not too dissimilar from what we were talking about before. Now let's talk about some of what happens after that. So let's imagine that like the lender can actually trigger this loan recall at any time. They can say, I need liquidity. I need to get out. Maybe the borrower realizes, oh, this is actually probably going to be expensive for me. I need to get out of it. I should repay this loan so I don't get hit with a really crazy rate, because maybe the value of my collaterals drops, or any number of reasons. So the borrower has basically the right of getting out so that they don't get hit with a shitty rate all of a sudden. And they can just repay that USDC plus the interest. And then all of a sudden their loan will just be unwound. So this lender will receive the USDC principal plus interest. So they're happy. And then the borrower will then be able to request to withdraw the Bitcoin from this custody account so that they're whole. That's like kind of a happy path. Now let's talk more about a refinancing auction and how that could work. So in this case, it's only lenders participating. Let's say the borrowers, no, I'm fine. Let it refinance, whatever. I'm still using my loan fund somewhere, and I want to continue that. So in this case, like the lender who actually owns the loan will request to basically recall it. This will then, after some period where the buyer can repay, it'll create this auction. And so then it's kind of like that first step where the lenders are bidding on the auction. Probably you imagine the interest rate to go up, but it could even go down. It's possible for it to go down. And then whoever bids the lowest amount will ultimately take over the loan. They'll have to pay back this original lender with that principal amount plus the interest, so that the lender, gets all the liquidity back and gets compensated appropriately. And then this lender will become the new actual owner of the loan. So that's like a happy path, like everything works out fine. Now, in the case where like really this collateral needs to be liquidated, the way that can work out is we basically have the lender triggers this loan recall, the borrower doesn't repay within 24 hours, and then no other lenders are willing to come in with that, increasingly high interest rate. And basically we can now assume that this loan is probably bad and should be repaid, but the borrower failed to. So we let that lender walk away with control over the Bitcoin, and, they're hopefully now able to be made whole. So to recap, the intention here is basically that this borrower can be using absolutely anything as collateral for this loan. In practice, like teams who are exploring this, they are like trying to kind of clamp down on what could be used a bit more. Like it can only be Bitcoin or things like that, just to make it simpler for the participants of this system as we kind of create it. But like really this marketplace contract has no idea what this borrower is using as collateral. They see it that this borrower is using a public key as collateral. So eventually you could build off of the same pattern and have this feel like a pretty complex set of collateral that this borrower is borrowing against. And especially as we have more sophisticated pricing of like risk, I mean, this is where there's some really exciting work being done in kind of the, machine learning space, artificial intelligence space, when it comes to pricing complex baskets of goods and thinking about all different types of factors. I mean, there's a lot of inputs you kind of have to consider here. The more assets you add to this, but you could actually get to some really cool models in the, really pretty near future. Okay, imagine there's probably some questions there. So happy to take those and walk back through any of these steps.
So Kendall has come back with an idea which is quite long, so we'll get to that in a second because you might need to read it yourself. In terms of questions, Reese has said, I'm not sure I understand the concept of liquidation. How does a person make back their losses?
That's a really good question. So again, I do not take credit for this idea. This is very much from Blur and the Paradigm guys. And I think there's this project called Astaria who uses it as well in production. But the idea here, so the problem that's trying to be solved, so like typically the way this is done is that there's an oracle that's like serving as a trusted verified price feed for the collateral asset. And usually the terms of the loan effectively include, like a max kind of value of the loan to the value of the collateral, right? The idea is like your loan should always be worth less than the collateral, so that if someone like a lender is forced to liquidate the collateral, they'll make more money than the value of the loan. And it also keeps the borrower honest, right? The problem we're solving for here is like kind of more complicated, or really quite a bit more complicated auction, is that the smart contract in this case doesn't know what the asset is, or if there has any context on that, which is flexible. And like the reason Blur came up with this is they're like NFT, it's really hard to get a price feed on NFTs for a variety of reasons. So they're like, well, what if we came up with a different structure where you don't really need a price feed? You'll instead create kind of like a market, like a emergent market around like a specific, really financial product that this asset is in, which in this case is a loan. So we're basically assuming we can't have an oracle. Like for a variety of reasons, it's impossible to have an oracle. So in order to still provide some protection to the lender, the idea here is the lender can auction off their loan. Like they're literally going to create an auction here. Actually, this one's the better one. It's like refinancing auction. So you have a bunch of lenders. You can imagine it could be like 100 lenders who are all bidding. This lender says, I need to get out. Like they own the loan. They're like, I need to get out. I need to get paid back. I'll give my loan and the rights to the collateral and the rights to any of the future interest payments. I will give that to someone new. Whoever is will, like in this case, bids the lowest amount. And the reason for that is we need to protect the borrower from getting, really screwed here, right? Because they're the ones who are on the hook for the interest. So whoever's like willing to step in and pay that lowest amount that gets this lender out of it, they have the ability to do so. They'll effectively just pay the lender all of the money that they are owed and then take over the loan. Now, if they don't do that, like we need to set some kind of threshold where, okay, nobody's willing to bid on this because clearly this is not a good loan. Like liquidation needs to occur here. That's where Blur, what they do is I think they said 1,000%. They basically they start the bid at 0. And then over the course of, I think 24 hours, every block, they increase the interest amount. And it's like, when anyone who comes in and is, hey, I'll take it here, they get it. I think that's how they do it. But there's a lot of ways to set up that auction. So the idea is, okay, the loan is clearly bad because no one's willing to bid on it. Now we just let that original lender seize that collateral and sell it. So hopefully they can recoup some or all of their, what they were lending. Now, I mean, one of the obvious problems here is that it might be too late. Like especially if they're using like a really volatile asset. I mean, even Bitcoin, of course, can drop, 10% in a day on a really bad day, but like it's happened, right? Some, longer tail assets might drop far more than that. And so that's why what we'll expect to see here and what you see on Blur is that interest rates tend to reflect the quality of the collateral, which is interesting because that doesn't actually happen on the pool-based models. Like you don't have a different interest rate for using Bitcoin as collateral on Aave as you do for using, like even the Aave token, right? Even though Bitcoin is of course much more liquid and reliable than the Aave token, but you're still borrowing at the same rate for USDC. I mean, that has some benefits, but it's actually not very lender friendly. And ultimately it does even restrict borrowers too, because they're not able to effectively, they actually just can't use, like a lot of assets just will never be able to be listed on Aave because it's too risky to the whole system. So like one of the benefits for this model is that it is a lot more flexible because you can, price different assets at different rates. But anyway, I know that was a lot. This part is definitely like the crux of how this particular idea can work. There's a lot of ways to do this. You can, of course, include oracles. It limits the collateral that you could have, but you still could create kind of a pool-based approach and use, a chain link and let people borrow against Bitcoin or Doge or Litecoin or assets that have price feeds that are reliable, but maybe don't have very good or liquid lending markets today. So this is just one approach that's like the most flexible, but maybe isn't always the best option.
I'm on mute, sorry. So Adam has asked, do you have plans in the future to allow tokenized assets to be used as collateral?
Yeah, absolutely. I mean, I think the cool thing here is that like you can expand beyond anything that is controlled by a public key can be used as an asset. So we can imagine, I think one specific example I think is really cool is that, right now, if there's a lot of demand for these liquid stake tokens, because people realize that you should be able to borrow against the Ethereum that you have staked. But there's no way to do that on Ethereum or really any chain without creating some kind of tokenized representation of that asset that can then be deposited into Aave and used as collateral. What's cool about chain signatures is that because you're actually boiling everything down to public keys, you actually could natively stake an asset using a chain signature's public key and then use that as collateral to borrow against. So I think you can kind of expand. You could even imagine people borrowing against like points or sold down tokens or these like traditionally locked assets that they would be unable to borrow against in the kind of current approach to things. So I would say absolutely, you can easily use any tokenized asset. And in fact, I think the system is flexible enough to enable you to tokenize assets that are pretty hard to tokenize today. And then all of those things can be used as collateral with a lot of different potential lending designs.
Someone else has actually asked a similar question. What sort of collateral do you expect people to use? That you've sort of just covered that. So for this last question, I think you're going to have to read it in the chat so that you can fully grasp
Yep,
it.
that's
That's really Fadil, the second to last message. I'll read it out for the recording just as you read it. So Fadil has this idea like trading of gas fees. So let's say that you have some extra gas fees on your wallet from doing some particular transaction. And let's say that you don't invest in crypto. What if you can list your gas fees to be used for staking and then getting returns back? So you're not staking a lot of tokens, so the risks are very low. Is there any project that is doing this? Or maybe you can expand that I try and think clearer.
yeah. It's an interesting question. This is exactly clear on this idea of kind of like trading of gas fees, but I can talk about some similar things that we're seeing. So the cool thing is anything that is controlled by a public key can potentially be used as collateral or potentially staked. And we're seeing some teams building this like kind of restaking for everything type of platform. Like a few teams in other ecosystems are also trying to do it. I think the limitation though is that you really are bound by can you tokenize? It's like step one, can you tokenize something? And there's a lot of work that's going to tokenizing something. And then once it's tokenized, you can use it as collateral. What's cool about this system is that it's actually more, can you sign for this with a public key? If you can sign for this with a public key in order to do something with it, then you can effectively trade and use whatever that action is, whatever that entire set of things that come with the idea of being able to sign with a public key, whatever that unlocks, you can trade the value of that. So like that could include some very exotic, like crazy things that we can't even think about today that people could come up with. Like it really is expanding the set of what you can do and what you can use. And so I think, yeah, there's some really interesting things you can do with gas tokens, with gas fees, abstracting them away, letting people use their assets in new and different ways, on new and different chains, in new and different products. So I don't know if I'm exactly understanding that question, but I think, yeah, you are definitely seeing it correctly that the flexibility here is expanded pretty dramatically, which was what we're really excited about.
Nice. Dylan's just typing, so we'll see if there's a follow-up to that question. But otherwise, does anyone else have any questions for Kendall? While we're waiting for this message to be finished typing out. While we're waiting, thank you very much, Kendall, for coming in and giving that presentation, especially for giving us another example. Yep, Kendall says, sure, thank you. And don't forget about the deck. I think they really want to see the deck.
Yeah,
I guess those
yeah,
diagrams are
happy.
quite
I would
useful.
definitely share it.
And also, everyone, this is being recorded and will be posted online. Giorgio has asked, is this product live? They joined late, so they missed.
Yeah. So yeah, excited to announce that, yeah, the product went live on mainnet last week, just about a week ago. So yeah, it is live and usable in production, and we have teams who are using it in production. So I posted a link to the docs, or rather not a link to the docs, but I posted, so the docs before. Let me just post the link so people can see it in this chat. I think I can post.
You should be able to.
But yeah, here are the docs. You can see the mainnet and testnet, of course, always test on testnet first, contract addresses that you can use, and how to do it, how to interact with chain signatures.
Very nice. How exciting. Giorgio, you can catch up on the rest of the session when the recording is posted, so don't worry. Awesome. Okay. I don't think we have any more questions. So thank you again, Kendall, for coming in and giving us this talk. I'm assuming that everything else is going to be, thanks in the chat. So we will end the session here for today. Thank you everyone for joining us. In the deck, Fadil really wants the deck. Enjoy the rest
I
of
got it. I'll send it over now.
We'll post it almost immediately for Dylan in the Discord, so don't worry, you'll have it in no time. Enjoy the rest of your days, morning, evening, afternoon, night, depending where you are. And we'll see you in the next Chain Abstraction Educate session. Thanks for joining us, everyone.
Thanks, everyone.